Hey everybody, this is Larry. This is my first time doing the Codeforce virtual contest here on video. Let me know what you think. Let me know, let me know what you think and give me feedback. This is my first time, so we'll see how that goes. Most of I'm not going to show um, my entire browser because there's really no need. You just have to know what problem it is. The link is to up there, and I'm just going to focus on my bash screen. And yeah, okay, let's get started. Hit the like button, hit the subscribe button, and yeah, let me click on register for virtual participation. I have to wait a minute. Is this a real? I don't know how these things work really. I've successfully registered, but I have about a minute and 20 seconds left. So we're just gonna hang out here, I suppose. And if you're watching it later on YouTube, I guess you have to fast forward. I'll probably put a link somewhere so you could skip a little bit. My bad. I didn't know how virtual contest works. As I said, I don't know how this works. So leave a comment about that. And yeah, and I hope everyone's doing okay in this turbulent times. Uh, Still a minute, so I don't know what to say about this. So maybe I'll just cut it out of the video later. But if you're watching this, then I might not have. But, uh, but yeah, I hope everyone's doing okay. Have good health, stay safe, and everything. Um, but in 40 seconds, we're going to start. Wish me a little bit of luck, even though I guess it's not ranked. Uh, I never know. I never know what I want from a virtual contest instead of like, do I want myself to do well and feel a little bad that I could have done it on the actual contest? Or do I hope I do poorly at be a little bit sad that I did poorly, but I'm like, I'm glad I didn't do that in the real contest. Let me know what you think when you do a virtual contest. Do you wish you did well, or you're like, oh, I don't know. Maybe you just where exactly you need to be. Okay, 5 seconds. So I'm gonna get my fingers ready. What is this 1358? So I do have a script 1358A. So let's get started. Okay, I'm gonna just open all the problems. I clicked on them earlier before I'm without looking, because I forgot to click on virtual contest. But yeah, let's get started. Yay! Okay, hey, so I am going to be talking a little bit more than I would during a real contest, to be honest. So it's a little bit slower than if I just, went heads down for a normal screencast. But we'll be okay. Just do it for fun. Let me see how it goes. A, park lighting. Due to the coronavirus pandemic, city authorities obliged citizens to keep a social distance. I need to read this a little bit faster. There's a link to the contest. Just check out the problem A. So I don't read it like I usually do. And there's the M columns. Each street has length 1. My reading ability is really slow today. Every street has length 1. For example, you can put lanterns in the middle of the street. The lamp lights 2 squares near it, and only 1 square if it stands on the border of the park. Okay. 7 wants you to spend the least amount of time, but wants people in the park to keep a social distance. Minimum lanterns that require lighting all the squares. Okay. What are my possible inputs? Input is N and M for the park size. So 1 by 1 and 1 by 3 looks like this. 2 by 2 looks like this. Okay. Is it just... I think this is something that I do have a notebook, and I recommend people do it as general, just drawing it out a little bit. I think if people who are smarter probably have see the pattern already, but I think it's a function of min row and min column or something like that. But um, so okay, so let's do it row by row, right? If 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 we do it row by row, then well, right now I'm really glad that this isn't a real contest. But if we're doing row by row, if it's odd number, then okay. Okay, so if they're both even number, then what's the situation? If they're both even number, then we just take the min. Wait, is it? No, we take the max of n or m divided by 2, right? Now, what? What am I talking about? Okay. Now, this is way dumber than I'm making it. But basically, they're m times n squares, and each light can light only up to 2. So optimally, all of them will get lit by 1. And then if n times m is odd, then you add an extra 1 to keep that one lit. I don't know why. Sometimes I make it complicated than it is. So now let's do that. I'm using old school C syntax because I'm an old school person. And then now we just have to print it out, right? What is n? 10 to the 4th, so 10,000. So 10,000 squares should be okay. So n times m divided by 2 plus n times m mod 2, I think. And then now I have a thing. I'm running the code compiling. My compile is a little slow. I should have warmed it up. On a contest, I usually warm it up by compiling anything, but today's a little bit slow. Okay, it looks okay. It's got accepted. So let's put it into the system. I really need to figure out a way to do this in command line. Right now I'm just fidgeting with the browser and I don't remember what directory my stuff is in. So I'm also glad that this part is not part of the real contest, even though I had some time to prepare it. Okay, what is this? 1350A. Okay. Now I'm clicking submit. Okay, so that's good. Problem is solved. I took a little bit longer than I should because I was being dumb. But okay, Maria is the most active old lady in her house. She's tired of sitting at home. She decided to organize a ceremony against coronavirus. She has and friends who are also grandmothers, grannies. Maria is not included in this example. Okay. The I of grannies right is provided there is a sub I other grannies are there. Okay. Note that the grannies can come to Granny I agrees to come if the number of other who came earlier or at the same time with her are greater than or equal to a sub I. Initially, only Maria is in the courtyard. All remaining enemies are at home. At each step, none of them have to. They all. The selected grannies will go at the same time. She cannot fool them. Okay. There's a lot of reading. Maybe doing this at 2 a.m. is not a good idea, but your task is to find the maximum number of grannies can collect for ceremony. So if I'm giving 1, 4, 5, I mean, the first thing we do is sort. That's what I'm thinking. At the first step, we do 1 at 5. Each of them sees 2 other granny going out. Oh, granny 5 to 1s. Okay. So 6 granny. Okay. I mean, this is just greedy. Sort and greedy. Right? Maybe we don't even need to sort. No, I mean, sorting is fine. What is, and then 6. So 2. What? Oh, do you count the Maria herself? Okay, that's what I was double checking. I mean, it's just sort. And then for 3, I mean, okay. So I think you can just do bucket sort or what you might call it, counting sort, and I think that'll be good enough. So test case n is number of grannies, okay, and then wow, n could be at most 10 to the 5th. And each of these numbers are 2 to the 10 to the 5th, that's fine. We might have to be a little bit smarter. I was going to do a counting sort, but if it's 10 to the 4th and then we do something naive of 10 to the 5th, that's going to be 10 to the 9th, and that is too slow. So we need to be a little bit smarter than that. Okay. Well, let's read the inputs first. Typing is hard. I know that I'm missing the N, but that's fine. I'm doing now. Okay. No, I mean, I think I'm just being silly. You could sort and then do the max. Okay. So sort A plus N. Okay. Well, let's just count from that. If A sub I is greater than I or something like that, then we can just print and then return. I need a better pattern about this. It may be off by 1, but otherwise just print 1 for the granny itself. Why is my compiler so slow today? Okay, I'm definitely getting the wrong answer for this one. You see on screen? Okay. 2. Oh, I think I had the signs wrong. Yeah, because I is the numbers of people you have, plus whatever, and it's also plus 1, I think. Okay, so I plus 1 is the number of people, and then plus the granny. Okay. Am I confident enough to submit? Yeah, I think I'm okay. It has the 1 case. That's the nobody case, that's the everybody case. Let's just download this. Actually, not super confident on this one, but okay, cool. What does this mean? Selects updates. Let's go. During the quarantine, this person has more free time to create a new function. Selects 2021. It's almost made a new function. Infinite table from left, from to the right and down from the upper left corner like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and the first thing to notice is going down is the triangle numbers. Named that way because of how you come across just now, I think. The cell of coordinates xy is intersection of what? What? What is the question before I kind of do all this upper? Okay, now we got this part. So goes into random. Calculate the sum on an arbitrary path from one cell to other, moving down or right. Formally, from cell xy, in one step you can move to the cell x plus 1 y. Okay, that makes sense. After another din while I just got to, that's Windows, I guess. Update Study select 2021 after from the table. The zigzag reverse function is to calculate quality of possible amount passed from given cell to another cell. If you can only move one cell down or right. Okay. Formally, consider all the paths from cell x1 to y1 such that each next cell in the path located either down to the right of the previous one. Calculate the number of different sums of elements for all such paths. Huh. Okay. Okay. Now looking at some outputs or inputs and outputs. So now we have from 1, 1 to 2, 2. We have two paths. From 1, 2, which one is x. X is the row, so 1, 2 is 2. To go to 2, 4, which is 9. Oh, sorry, that's not 9, that's 12. So let's see. I'll just draw it out real quick. So 1, 2 to 2, 4. What was it again? Because I already did it first, 12. Okay, and xy, what is this number? That's weird, but okay. Xy goes from 1 to 10 to the 9th. So basically we have to find something that's smart. Okay. My first question is it just the number of paths? Because if it's just the number of paths, then this is not that tricky, but maybe. Okay, so this is strictly down to the right. Number of different sums. So 3, 1, 2, 3, I guess. I mean, this is way. I think from the way that this is constructed, it is just a number of paths from like two regular cells. Like there's some Mabian of restriction. Of just trying to throw there to confuse you. But that said, is that even true? Okay, so I think what I'm going to do is just implement the dynamic programming one, and then I kind of see if I figure out any patterns from it. I mean, it should be just delta. It's like delta, or yeah, delta x plus delta y, choose x or something like that. Or delta x plus delta y over, or choose delta x or something like that. But I don't, but that could overflow, so I don't understand if, okay, let's do 3, 5, 2, no, two cells arrays are always going to be the same. It's always going to be 17, this is always going to be two ways, two sums. Let's try the 2 by 2 case, 1 to 13. Here, there's only one sum. This is, by definition, they're different. Off by 1 because of the way they do diagonal. So I think the part that I'm confused about is try to understand how this doesn't overflow, unless I'm really confused about something, which is not unlikely. Because of the way the diagonal gets structured, but then I mean, it's still like a mod. I think the thing I'm also confusing about is that why is there not like a mod or something that we can mod by? Uh, because that would just like crazily overflow it. Like if you imagine just 1 1 to 10 to the 9 to 10 to the 9. Oh, that probably seems to hold, but am I missing something really obvious? Maybe. Let's write a brute force algorithm from real quick, and then we'll kind of see if I can analyze it in a way that that makes sense. Okay. Uh, hmm. Yeah, let's just construct a 5 by 5. Um, what is I sub j is equal to I sub j minus 1 plus the row number or something like that. Row number plus item number, so like this. Give or take -1, I don't know. And let's just do this as 1. Then a sub I sub 0 is equal to a sub I plus 1, 0 plus so plus I plus 2 or something like that. Yep. Let's print that out so we could see. Also, I should probably put these in a constant so I can muck around with it later. Okay, So I'm off by a little bit because we start by this thing, but that's fine-ish. Okay, close enough. First one was right. The second one, I guess. This is I plus 1. So yeah, so we generate this thing, which seems like it's okay. So we did do that really quickly, actually. But it's just triangle numbers, so it's not impossibly hard. And now, what's next? What's next is, let's just do a brute force from 1 to, let's just try some small numbers. Try brute force from 1 to 3, I guess 0 0 to 2. I'm using C++. This is not C++. Sometimes I still think in Python, unfortunately. Okay, and then now let's just do some craziness that I would have to. I mean, this is literally code that I'm erasing anyway, but still, it feels sad. Okay. Oh, actually, what we want is a set to test our hypothesis. Otherwise, we add the current number and then we go left and then we go right. Oh. Oh yeah, we want to do it with backtracking, right? So, oh, this is not. No, that's right. Okay. No, we don't need backtracking. This is just pure. Plus. Oops. Oopsie. I guess we have to make it global. From that, we do need to check that x1 is less than x2 or equal to, or oops. Okay, and now let's just print out the size of that set. Okay, so the answer is 5. Is that right? I forget. So 5 seems. What was it? What is? What did I say was 4 choose 2? That's not 4 choose 2, right? Pick out calculator. 4 choose 2. Oops. Okay, then pick out Google then. 4 choose 2 is. What am I thinking? It's like 6, right? So 5 is not right. That's well, it's not. Doesn't match the pattern. Let's print it out. This set. Okay, so it's only 15, 16, 17, 18, 19. Let's just do a quick this just so that I'm double checking my sanity, and this should be more than 5. Yeah, that should be 6 as the estimate. So this 5. That means that it is not just x times Well, delta x plus delta y, choose delta x. That is interesting. Now though, we can play around the numbers. Let's try 3 to 18 is 7. But basically, it seems like you get the min and the max. So we just have to be able to figure out the shortest path or the smallest minimal path and the largest path, right? That's the pattern that I'm noticing. Let's try another number. Well, let's just do 4, 4, I guess. That's the biggest number. But yeah, it seems like, so I do see this pattern now. I hope you see it with me. And the shortest or the smallest path is just the sum from going to the right and then down. And then the max sum is going down and then right, I think. So now we have a strategy of kind of figuring that out. Okay. I wrote all this code just so I could write code. Okay, let's do, I mean, I'll get rid of that code soon. But what is my inputs? Okay. X1, Y1, wait, is it, what, okay. X2, Y2, also I probably need long longs, actually. I did not actually prove this, but I figured that it sounds right. Okay, and then now, luckily we already have this formula, so okay. So let's see. Going right first is this thing for 0. So right first is min, I think, yeah. I don't know if those are keywords. Okay, but we also have to find out. Oh, we have to do this. Actually, I kind of got a little bit lazy here. We actually have to find this a little bit better, right? Because, actually, let's check something real quick. I think I start from 0, 0, but maybe that's actually not necessarily true. Let's try this real quick. Okay, I guess still true for this case where we go from 2, 2 to 4, 4. So 13 plus 2, that's 2. Just validate this real quick. Well, I don't, I don't include the 41 in the total. That's why these numbers are a little bit off. And we only care about the delta because 41 is in both of these. So, okay. So that seems like the correct way to solve this problem. But there's still more math involved. um, that makes sense. I think you could actually come up with that analytically or logically, but I was not that smart. Okay. Well, first we have to figure out, given x1, y1, we have to figure out what the cell is, or what the number is on that cell. Let's see. So the first number in the, okay, this is where I used the paper, but this is just the triangle numbers. So the x1 number is what? What is it? It's like some like n choose 3/6 or something like that. I don't know. Oh, wait. N plus 1 choose 2. What was I thinking of? That's not right, right? Yeah, I guess that's true. That makes sense because it is the triangle number, so it's n plus 1 choose 2. So, okay, that means it's just, uh, well, actually, I think I'm making it more complicated. I mean, I still need to formulate this, but because we only care about the delta, and the delta doesn't matter where you start. If you shift everything up to the left and the right, then every cell gets subtracted by the same amount. Is that true? Dun, dun, dun. Yeah, I think so. So in that case, because you look at if you look at the this if you look at this matrix, we can shift it to left by 1 without a loss of general. Is that true? Yeah, I think so, because here everything minus 5, but this is only minus 4, but then this the delta is also minus 1. Um, hmm, I think. Yeah. So in that case, you can actually just do x2 minus x1, y2, y1, and then now we just have to figure out the re-indexed. Now we just have to figure out the re-indexed thing, and then now the 0th row will be the first row, give or take. So now we just have to do, yeah, let me double check this real quick. So now we have a formula. We want to make sure that it is what we say it is. 10. I just want to make sure I get the off by 1 right before I put it in. Okay, so this is right, except for we have to start at 1. Okay, so if it's 0, so again, I guess it doesn't matter because it gets, no, you need to off by, okay, I'll just do it that way. Okay, so that way, and then that, oh, yeah, okay, fine, let's use different variable names because this gets a little bit confusing for me. I am not a smart man. Dx is equal to x2 minus x1, and then plus, I guess also this is a typo, but let's call it xy. So x is equal to that plus 1, y is equal to y2 minus y1 plus 1. Okay, how much time do I have left? A minute 24, okay. So now, can print out. Is there a smarter way to do this? Because so what I was thinking is going left and the right, but we could calculate it from just the delta from these squares, um, from the things, and this is, so the first diagonal is going to be plus 1 delta. This one has plus 2 and then plus 2 plus 1. So you have 1, 2, 1. Is that good enough? That's 4, so that means it's 5. But what if it's 1 by 2, right? 1 by 2, then it's just 1, 1, and then that's it. So that's why it's 2. Okay, what is the answer for 1 and 2? 2, okay. Oh, I was in the middle of typing something, probably. Now this is 3, so given if we have just this is 1, 2, and then this 3, oh no, it's 2 plus 1. Okay, So basically for you diagonal, so this 1/4, I think I'm starting to slightly see the pattern. Is it just m times, well, in this case, x times y plus 1? 2 plus 2 is 1, 2, 4. Now, because you have this long thing, right? Is that the only special case? Because every other case we compare the diagonal, but the one case is okay. Maybe that's right. If x is equal, and now we just keep track of the delta. I think that's fine. And or y is 0, then in that case the answer is just 1. Otherwise, we're all able to compare the diagonals, and one, two, two, one for 2 times 4. Let me try something real quick. I don't need this anymore. I don't need you anymore. I'm gonna need the small and the big. The answer 1, 2, 4 is 5. Yeah, okay, that makes sense. I actually mucked up. Should be 1 more. It's 12. 2 times 4. Is that right? Oh, wait, there's a 58. Don't. Oh, but that's because I go out of bounds. I think I didn't construct my max to be big enough. Okay, let's try again, and hopefully this time with the bigger correct answer. Okay, still 9, which is 2 by, okay, well, I hate everything this farm stands for, kind of. I mean, it's interesting and it's fun and it is exploratory, but it is, it is unfortunate. Let's run this real quick. Oh, right, of course. Thank you for reminding me. Okay, well, that was fun. Okay, let's submit this one. Where's the submit button? That's a cute poem, though. I wonder if people did it quickly or not. I did not do it quickly. Okay. Okay. That's cute. Got an hour and 20 minutes, so let's just take a peek at my standing. Would have been, I don't know where this comes up. Okay, well, not very good apparently. Did they not tell you in the virtual contest? I don't know how these things work. Like where am I? I guess I'm spending too much time now on this. But I'm just randomly curious. Wow, people are really fast, so well, again, now I'm once again happy that yeah, happy that I'm not on this one. Maybe I'm not actually, I don't know. I don't know how this virtual contest works. Is there no virtual ranking? Okay, whatever. Wow, but look at this, seems like 1,000 people got C though, so Wait, is that 1,000 now, or yeah, probably not during the virtual participation. It is way confusing. Okay, maybe I just don't care that much about it. Um, yeah, but I mean, this is good enough. We'll figure it out later. 41 minutes, but okay, that's actually so far than not try to figure out how virtual contests work. So that's okay. I mean, this is not that serious. You've been in love with coronavirus Chan for a long time, but you didn't know where she lived until now, and just now you found out she lives in a far away place called Naha. Okay, there's too much reading. Your vacation lasts exactly X days, and that's the exact amount of times you will spend visiting your friend. You spend exactly X consecutive days visiting coronavirus Chan. Who, who even writes this? They use N months in a year. I month lasts exactly these 5 days. I guess you have an array of days, I think. Um, and no leap years. Yay. The moon depends on the day of the month. You get J hugs if you visit Corona. Okay. So you want to maximize the hugs. Okay. Please note that your trip should not necessarily begin and end in the same year. Okay. That makes sense. The number of months in the year. There's a lot of months in the year. The number of days you can spend with your friend. The days are in 10 to the 6. So you can't do any brute force. I mean, it's a D, so I guess makes sense. Okay. What is 3 again? Oh, exactly X days, and is the number of months and the days that you could spend. Okay. Hmm. And what is X? Oh, X can be any amount. So and X could be the entire year, but just 1 year. Hmm. Okay. 1, 3, 1, 1. Can we do some sort of greedy? Hmm. Okay. I was actually changing the topic, but okay. I mean, I think that by the way this is structured, what you want is some sort of greedy where, yeah, for example, you always want the biggest number because if the way that I'm looking at it is, and usually I would write this in my notebook, but I want to visualize it for people at home, uh, or I guess you could be out and on your phone and watching me, but you do whatever you like. I'm no judgment, but yeah. Anyway, like 5, then on this side will be 1, and on this side it will be another, say maybe 5, 4, 3, 2, 1, right? Something like that. Doesn't really matter. But but given that you're say here, you always want to go from higher to lower, and once you are here, hmm, then it doesn't really matter either way per se. Well, you probably generally want the 1 as well because this leads you to a bigger number to the left, right? So you almost want to take the entire way, though I might have to think about whether there's an edge case where you want to do this, because that one makes sense as well, right? Um, oh, that's going to be a tricky case, but that's just one case, right? Because, um, yeah, can but but in that case, I think what ends up happening is if this goes over the number of days, what happens is that um, in theory, you always get a better answer by starting later and then going back and then grabbing the 5, like, right? Like you only grab the 5 in that case or something like that. So I think maybe there's some, I mean, proofs and greedy stuff is a little bit hard for me. Um, but that's what my intuition is telling me. So then now what that means is we have to figure out some way of um, yeah, I think this, going back a little bit, I think this makes sense because, uh, yeah, if you have two choices to make and you could choose the one on the right, then eventually you just shift the entire thing to the right, and then it'll be your right. Either you choose your right because n is bigger on that right mountain or whatever you want to call it, or it's smaller, but then you add it to your current thing, so then that'll be your edge case anyway. So I think from that perspective on, you always want to, unless you have so many days that you run over, you always want to end your last day on one of the bigger numbers, or sorry, on the, you always want to end your last day such that it ends on the last day of that month. Yeah. Okay. And from that, what does that mean? Hmm. Can we brute force that then? We can keep a running count of this going backwards of all the summations. Uh, to think that's a little bit tricky about that, it's essentially what you're doing is a sort of a sliding window. Um, and that's fine, except for now where that sliding window has some like off by one type things. Um, but we can do that. I think that's just sliding windows then, actually, right? You keep on adding indexes to the right, and then you do a math on how far you can go back using your other pointer. Okay. Um, hmm. Am I don't know if I'm convinced on that one, to be honest. But let's see what the second case is. You, in second case, the number of days are 1, 2, 3, 1, 2, 3, 1, 2. You get more days revived on the third day of the year. Um, yeah, I mean, that makes sense to me. But you could just do this, right? And it's just 12 as well. Okay. Uh, yeah, and we just have to duplicate the array twice to loop it at least 1 year. That's fine. Okay. Am I good enough to start coding? Yeah, let's give it a go. I think if I have to rate my confidence level now, it's not very high, but educational value we'll see. But I think that's enough for me to start on the and yeah. What is it? Two, five. Okay. Let's double it. This is just one input. Okay, so I could just import this stuff. Okay, and then now that's duplicated. and then set I, shift 1, just double it. Okay. And then now let's do the sliding window and the max. I'm calling them left and right. Sometimes I call them head and tail. Gotta be consistent. Left is equal to right is equal to 0. Okay, so let's start it at, so left is, let's just start it just for now. Wow. So now you have your left and your right, and they're both at the same place, so that's processed to right. Best is equal to the last I need prefix sums, don't I? Just so that it, yeah, okay, you're right. A sub I plus B sub I minus something like that. Okay. Now that's I am a little bit tired though, I'm not gonna lie. This is what happens when you start this at 2 a.m. How much time do I have? 1 hour, okay. Maybe my last problem though. Let's add what the, what so current is equal to, let's just say, prefix of right minus prefix of left, and then now we're going to just okay, so it's incremented while current bigger than x. So this should always terminate because eventually right will equals to left, so that's invariant there. And then now, after we terminate the loop, we okay. So left over is equal to right minus p of left. Let's create leftover. Right. So then, otherwise, our current hugs. So if we process right, then well, that's current hugs is equal to a sub 0. Choose 2, right? 3, 2, 1 is 6, so that's 6 factorial. What am I saying? What am I doing again? Oh yeah, the sum of this, which is right. I am really a little bit slower today. No, this is just and choose 2, right? Yeah. Don't be silly. And also because we do this, we should make it a long. I don't think it matters that much for memory. So 256, okay. Yeah. And then when we process left, we minus this. Also something that we can pre-calculate, but we only do it once actually, so maybe we don't actually. Yeah. Okay. I have a best. I do have a best. I'm the best. I'm just kidding, by the way. Banana best is good. Max of best. And what do we call it? Current. So we don't take count leftovers now. I just want to run the code just to kind of see where it leaves us. Line 20. What am I doing? Oh, yeah, that's why I changed it to this magical thing. Okay. Output is 1, output is 6. That's not right. This one, because there are no leftovers, I expect these to be a little bit right. I just print it out then. Little malpractice, let's put it to standard def. Standard air. So, okay. It seems like there's some off by something else. Because this should not be negative. This is wrong. So, oh, I never added stuff back in. That's why, okay. Yeah, okay. This is actually before. It's still wrong, but a little bit less wrong, hopefully. This is 6, so there's no way that was going to go. What is the answer for this one? Okay. So this one, I expect my answer to be 2 because the 1 and the 1 goes together. Okay, so I'm wrong in the correct way because we don't take account leftovers. Okay. Okay. So now let's say we have leftovers. Then we want the leftovers from a sub left. Okay. So if leftover is greater than 0 and left is greater than 0, now we just left is what we removed. So it should be left minus 1 is greater than 0. Maybe. That should be easy to check that. Okay, so that is just a sub left times this thing minus something like a left minus leftovers times a left minus leftover plus 1 over 2. Something like that, right? This is just trying to okay, let's just do let's just do this for now, and then current. Oh, right. Yeah, I guess we have to leftover bit leftover bit count, naming the sort. Otherwise, I just set that to 0. Yeah, okay. Yeah, okay. Well, can't be perfect. Okay, let's print some stuff out then. Okay, so 1, so okay, and then leftover count is 1, so makes it 3. If left is equal to right, and we take 2, so this should be here, but what is the leftover count? Is this it's x minus this, I think, because that's the count we get. Okay, well, closer. I just pointed out. So the leftover is 2, but we get 1. So what is a sub left? A sub left. My lefts and my rights are a little bit off. It's off by 1. Because right should be before it's processed. Okay, fine. That's why we're not counting that. Okay. Well, this is just wrong, but at least maybe it's a better progress. I don't know if that's true. Now, because right has to be, yeah, no, this has to be 1, but for the prefix sum, but this one is, this here may be a little bit off. So, or 1 after, that's fine, 2, yeah, here should be, okay, that's where, should be -1. Okay, there we go. And leftover count has to be, I think there's something that we have to check that leftover count is smaller than, well, that's the leftover count is the number of hugs, but leftover has to be smaller than, well, basically, this has to be, and a, because otherwise you just should take the entire day. I think this cannot be true, but I don't want to think about it. I don't want to think about proving it. I'm not actually, I think at this point, I'm not that confident about this problem, even though I got it okay. But let's submit it just because we have 51 minutes left and I'm doing this at 3 a.m. because I'm a silly person. So let's just submit it and see. Approved by AC. Uh-oh. Ah, I guess I never do one where it's it is there a problem where we spend entire 12th day of the year? 3, 4, 5, 6, 7, 6, 9, 10, 11, 12. I think I didn't test the wraparound one, but and also let's double check our math. It's all in long longs. What our number is 10 to the 6, so it should be okay. In that this should still like I'm just checking whether it could overflow long longs. But seems okay though. Okay. I do not check the end of year situation. What's a test case where that is the case? Let's copy paste this bit. Let's just do 8 days, so it should get, in theory, it should get both the 4s, so is that right? What is 4 times 4 plus 3 plus? Oh, so that's right. How about 9 days? 21. Okay. So that's one of the edge cases that I worried about, but leftovers. No, we check that it's quicker than 0. And leftover count, by definition, this should be bigger than 0 or 0. Assuming we don't do anything funky. This is tricky. Debugging without knowing what's going on is always going to be a little tricky. Just look at the constraints, see if I missed anything obvious. But alright, let's try. What is x? X is 10 to the 6 times. Are you serious if that's the case? I did not. I did not. I hope that's not. I mean, maybe for the sake of me being able to sleep, I hope that that's the case. But that would be a little bit sad that that's the case. Okay, let's try again. Usually, I probably test a little bit and find a case where that is not the case first. Something that I correct, but I am. It's a little bit tiring. Oh, this is both frustrating and also happy, I guess, because it's like this is a hard problem, right? Or a hard for me problem, and like getting it right, but except for that thing is a little bit annoying. All right, let's see if I could do more. It's a little tired. We have 40 minutes. In theory, I could do one more problem. Um, let's peek at the standings. How many people self? Wow, a lot of people self four. But so in theory, I don't know where I am, but what are we? Like an hour and 15 minutes in. So in theory, I don't know. I don't know how these things work, but let's say top 400. Oh no. Well, yeah, we're definitely beating top 400. That's good, right? I don't know. I thought it's supposed to show up. I could have sworn it did, but I don't know how these things work. But anyway, let's see if I could do more problems. Um, are you fired? Always happy to know about it. Consecutive months. What? This is so. I'm not reading the problem correctly, but I am going to stick at the standings one more time. Not just this time, not to see the rankings, but I want to see the relative difficulty of the problem. Okay, so about 16 people solve it right now. Okay. So like a rolling sum for this point. So for k is equal to 3, it was like 0, 3, 5. Okay. Fortunately, at least one is not a profit. Find any k such that for each k months in a row the company had made a profit. Well, we put that as impossible. This is what we call in the business a hard problem. The first line is the number of months. The second line. Okay, so basically it's just 2, -1, and then, well, in this case, just 3, so it's 2. Um, hmm. I don't think I mean, I still don't have quite an idea. Um, can you binary search? Yeah, that's a lot of stuff. Was that 5, half a million? Half a million if we do a binary search on 2 times 10 to the 9th space. Maybe not even. No, we do a search on k, which is less than this. So that is 20. So that's 10 million. Is that fast enough? I guess so, right? I think the other thing that I'm a little confused about is the income is the same at the end. Does that matter? Hmm. Hmm. Like, I think some of the thing I would say is if if um if we could just binary search, and I'm not convinced that I can or cannot. Um, why the end over 2 in the last month? I wonder if that's something to be take advantage of. But I think I'm gonna just start with playing around binary search. I don't know if I could get this far in 40 minutes, but let's let's see why it wouldn't work. But yeah, sliding window on the binary search should be okay, right? Wait, can you do a binary search? Let's see. Maybe that's. I didn't even think about that. I mean, for a given k, you can check whether that's possible, but but whether k is possible or not does not tell you anything, right? Like like k is equal to 1, so obviously not possible for a lot of these with just negative numbers. But k equals 3 is good. And conversely here, you cannot just take, well, k equals 1 is not good, but also k equals the entire array is also no good, right? Only k is 4 is good. Oh, excuse me. This is also why I don't stream longer ones. It's kind of hard to stay focused. Hmm. I mean, we definitely need to prefix sum. Can we do some math around that? Trusty notepad time. This one's not possible. So it's only possible if for every negative number, there's a way to make that positive. Negative 2, 6, -1, -1. How does that? -2, There's, I think, I mean, there is something that reminds me a little bit of something. for each number, if I do a binary search to find the minimal number. No, but that doesn't make enough sense, right? Because again, even trying to find the k, even for this one number, if you go one too far, it may not be good enough, right? Is it zero greater? I actually forgot about that. Not a profit. Okay. Anyone self F? I think that's the other thing is if someone self F, then maybe I could skip ahead a little bit, but it seems like that's not an idea I should pursue. Okay. I think I have no idea. No idea. No idea. No idea. Hmm. 35 minutes. So what I'm doing right now, can't really see it, is, and I'm maybe stalling by explaining it, but what I'm doing is just scratching chicken scratch on a notebook just for ideas. But like I said, there's no guarantee that I know how to solve this one. Take a look at F real quick. Oh no, the coronavirus caught you. Given two arrays of A and B of size n, you reverse it, you can put another prefix. Okay, it seems constructive. I might have to think about it later. But well, we can choose any k. Is this one of those constructive? Well, if it's positive, what does it mean? I think we should. It makes it seem like I always want to choose k such that it takes half the array if it's positive, and if it's negative, then it's as much as possible, because anything smaller than half cannot possibly be the answer, right? Okay, so if it's positive, then we can just choose a k such that is k constraint. Because there's some sort of like pigeonhole thing where if this number is positive, then you want all of them anyway, and because of the entire sum is not Yeah, right? Because you want the entire sum. And then if it's negative, what does it mean to be negative? Because if it's positive, you want the entire contribution in either case, because why not, right? So you choose a case such that it is like n or something. Do we have any constraint on k? No? Okay. That sounds right. If it's negative, then we might have to, so we only have to consider the negative case. I mean, even 0, you want all of it. Well, it doesn't affect it anyway, right? Because if there's such a way in that a substring gives you a positive number, then you can add all the number, or is that true? Like, can you construct like a 1, -1, 2, -1 case? Yeah, I guess that's not necessarily true. And you have zeros all the way around. Well, if you have zeros all the way around, that doesn't really matter. Because what case you got 1 or 2 doesn't really matter. So let's say 1, -1, 3. But that, even in that case, it doesn't really matter, right? Because you want all the numbers. Okay, so I think since we only have 30 minutes, that's going to be my hypothesis, is that if this number is positive, then we just want the entire array, and we only have to check once. If it is 0, we treat it like it's positive, because why not? If the entire thing is part of it is negative, then it's just not possible anyway, right? Tricky case is if this is negative, then we want to choose k such that we can handle that. Almost like a reverse cadence algorithm kind of way, going backwards. We take the max, and then we try from that index. Yeah, I mean, I have half an hour. I think I'm just going to give it a try. This is a freebie, I think, in some sense of the word. And also because it's a virtual contest, so we'll play around the idea and then we'll see. Okay. Let's read n. Oh yeah. N over 2, n plus 1 over 2. Okay. Yeah, I feel we're going to need long anyway. What's max n? Half a mil. I think half of these are not whatever, but okay. And then now, oh, we have to scan in the n first. And then now we have to scan in the rest. Okay, I just got off. Some, or do they have a name for it? Oh, X. Okay, fine. X. Oops. So X should be long. if we are doing something related. Okay. This is it. So this times this number should be okay. N times x should not overflow. But okay. So what did we say? If x is greater than or equal to 0, we just choose k as equal to the entire array, because then we get all the benefits anyway. Yeah, okay. In the negative case, we just choose the max. Okay. Yeah, we'll choose the max of the rolling sum. I think that should be okay. So k is equal to n. If, let's just say check k. And print k. Else print was a -1. If I is greater than or equals to k. Okay. And then for every step of the way, if current is less than 0, return false. Otherwise, 1. Okay, that was pretty bad ergonomics. It was okay for writing, but not for typing. Okay. Let's check this real quick. See if the first answer gives me the right answer. Okay. Okay, so that should be the right answer. This not. Oh, where? Why does that happen? Shouldn't that? Shouldn't that be? Oh, I don't do anything with the x. Okay. Guess you can do some with math, but oh no, still gives me a 5. A 5. Zero. That's what I expect you to say. Shouldn't this triple it? this is also 0, so that's a little bit suspicious. Just a little bit suspicious. Oh, bit suspicious. What is going on? Oh, whoops, I moved this to the top, but I didn't do that. Oops. Okay, that slows me down. Silly mistakes. Okay, so example 2 got correct finally. But that means, and this one's correct. So I think we just have to handle the negative case, which is a sort of, what were we saying it was? Max. We just have to find the max case. That's 0. Zero. And now for, oh, just one correct again. For I is equal to n minus 1. Okay. If clean is bigger than, it's better than best, meaning it's at least better than 0, then k is equal to from I to n minus 1. Plus 1, I think, so something like that maybe. I think tiebreakers want just to be longer. I don't know if this is right, to be honest. Probably not at all. Cannot prove it correct at all. Let's see what the k would be. Now this k would be 4, so we test the 4. Okay, let's try that then. Who knows? Who knows? Okay. Oh, gives us -1 for 4. Oh. Why is that? That should not be right. Let me check one. 16 minutes. 4 negative 2. Oh, I see. This has to be in here. And this, no, rather, if I is greater than k minus 1, that means there are k numbers in the set. Then we check. Okay. Oops. Just got a little bit lucky on the other ones, I guess. Okay, let's see how that goes. To be honest, not really confident about it, but with 15 minutes left, decided this one I give up, I think. I don't know of any other way of thinking about it. I mean, that's a positive sign. I might not give up if, like, it means that maybe that, okay. Because 22 is really a lot of answers to be wrong. So what does that mean? That means I'm missing a case. I mean, in this case, it shouldn't be, what could it be? I mean, this case is not into a long thing because I do all my calculations in longs. In longs. I think this, the only thing that maybe is greater than equals. That one I wasn't so sure about whether it should be one or the other. And I'm not so sure that we need this to be the best either. It's just more like if this is greater than. That's all matter here. Okay. Why does this, what is this K in this case? K is 5. Why is K 5? So is it the best? I'm just going to yellow this one by changing the signs a little bit. Because I wasn't sure if I need to be the biggest or the smallest that that still fits. And again, I don't know how many more of these that I can do. And this seems like it's the wrong answer again. Okay, Or in terms of, I don't know how many more possibilities are there. Um, okay, maybe this is one of those things that requires some maths that I don't know, but because so at least that wasn't the case. But I wonder what the case is that leads you to. I guess I could imagine a case. I just don't know how to figure out how to do it without brute forcing all the case. Um, hmm, let's see. 10 minutes left. So it's not looking good for this problem. So, also, it's possible that I just missed an observation that I don't know. If it's negative, okay. If it's negative, what does it mean? Well, maybe I just got lucky on this case, but that it so happens. Because why not 5, even though it's positive, right? Hmm. It's either that I'm also thinking of like some delta of like um, if we choose k such that, I mean, in this case, k has to be greater than n over 2. So that means that there's going to be overlap in the middle, right? No matter what. Does that give us enough to binary search or do something funky like that? Because you have a sum for the left and you have a sum on the right. And if your sum on the left is less than k, then that's not good. I think maybe I think I have an idea to play with. It's 9 minutes. I'm a little bit too slow now. Maybe we could do a rolling sum the other way too. Then it should be. Let's just keep it simple. I don't know how. Probably with some array manipulation, but I'm too tired to think about it. Okay. That somehow worked. Let's take this out. I'm probably a little bit YOLO submit, but there's 7 minutes left. What's going to happen? Ah, of course I was a little hopeful, but yeah, well. I'm just clearly just trying anything to see if it works. Which is something that I do if there's only like 5 minutes left. Why not? Right? But because I don't have enough math to prove this. Or I don't know. Just give me the wrong answer. Yep. It's worth a shot. Is there a fast forward button? I think I give up though. It's just test 22. I mean, I think it's just, okay. That's fine. Okay. I had a good time. Was that E? Yeah. Wow, a lot of people subbed. Gee. I still don't know how this ranking works. I guess now I can ramble about it a little bit. Yeah, I think I'm GG. So I'm gonna bring the chat back up. So how's everyone doing on the chat? I don't know if anyone's still around, but wow, someone subbed E but not D. Impressive. Yeah, 4 minutes. That's self 22 answers, but I guess it's just not good enough. Yeah, 25 for self F, really? Didn't see it. Oh, because of the unofficial people? Well, if there's only 25, that's actually a pretty hard bar. And 200 pure self F. E, Okay. Well, I mean, this is not a real contest. I don't have to wait till the end. That's fine. I don't know how these standings work, but I am gonna just start going over the contest and just try to figure out how to learn from this, I suppose. Okay, so it won't let me quote unquote cheat until the 3 minutes is up. Is that right? Like I just want to look at other people's cases or even my cases. Like why am I not in this rank? Sadness. That am I? No, I don't think I have enough. The top 200. I'm probably around. Wow, 56 minutes. That's impressive. But I feel like I saw the last one at like 120-ish, so like something like here-ish, maybe. No, because my third problem was much slower. I just stopped the third. No, I mean, I think I stopped at like 40 and whatever, right? I think it tells me, right? 57. Yeah, it tells me at 41 and 113, so plus 1, so probably like literally on the cusp of top 400, give or take. And this person is doing the same strategy I am with the 13 submits. But yeah, okay. I'm just gonna hang out for a couple minutes until I can quote unquote cheat and look at the solutions. Note that you should find the exact value of the answer. You do not need to take it module. Oh, that would have been nice to read this announcement. I mean, I think I did not read it. I don't know when that came in, but because I spent some time just thinking about that, I was like, huh, isn't there some weird thing going on? But hmm, okay. I mean, I guess I could see if there's is there an editorial? Didn't even look at F. You're right. Oh, there is an editorial. Let's put read the editorial together. Uh, yeah, okay. Is this one? Yep. Okay, picture. Okay, I should. These pictures, I don't know what I expect. Tutorial, pop lighting. Just one side of even, it's gonna be. Oh yeah, I knew that. If both sides are odd, then you have to add the one. Oh yeah, that's a queer way of setting it. Okay, I mean I knew that one because I submitted it. And just trying to find my times. 5 minutes, give or take. I was a little bit. I mean, I wasn't rushing it. Okay. So second one at a time, then everyone can say granny. If X is the maximum answer, then yeah, basically, if you order grannies by A sub I, then code X. So to find X, we could do a linear search. That's what I did after sorting. Yep. Okay, so X, the minimal sum. Let's look at such a change in beats along the way. That's essentially how I did it. You could change the path such as +1. I mean, I was looking at the diagonals from the smallest and the biggest, but yeah, this is a really weird and hard formula to come up with now. Okay, D, I did this one. Okay. We double the array and solve the days. Oh yeah, yeah, this is easy. It's just whatchamacallit. Uh what? Unlock it, really? I did this in linear, right? Didn't I? Uh, I mean, maybe I sort. No, I don't even sort. I did this in linear time. Okay. Huh. Why is there a binary search? Yeah, that's what I said. Yeah. Okay. Okay. Binary search to find which one contains the less bonus k days less than the right one. You can use C to. Huh? I don't know. I don't know if that I get this binary search because I did it with. Okay, fine. As I said, I did it with a linear, just math. Basically. Yeah, I don't know. This seems unnecessary, but I guess that's good enough. I mean, they probably did as well. Am I fired? Let's take a look at this one. Am I fired? The reported incomes, then there's a K, and K is less than 2. Uh, if some K exists, there's also K that's greater than equals 2. That's what I said. Let's notice that. No cubic sum, okay. If Sk is greater than or equals 2, A sub K sub J holds. So when you increase K by 1, I think I'm missing. Oh man, it's 4 a.m. I really did not. I'm not smart about this one. Okay, so consider. Then we put in s sub I and s sub I plus k. Okay, so those are prefix sums. Notice that we double k. I if we put income will be equal to s sub I plus disappear. I don't know what s sub I is, so okay, this is just prefix sum, okay. Oh, okay. I mean that makes sense. So how when we increment k by 1, then first one is changed, last one is removed, and that's it. Don't know that I understand that part. We call s I is okay, so this is just some smarter way of doing prefix sum. I don't know that I understand this solution, to be honest. And I'm not even okay, there's another solution which is simple for me. Okay, prefix sum. Oh yeah, let's see if I could see what this test case 22 is. Hmm. Well, definitely did not get that. I don't know. It's just a really big answer. So S sub I is equal to pretend is such a k such that sk is greater than. I mean, that's what I was trying to do. Numbers to the right of x equals x. Okay. X is greater than 0, in some cases, in the case. Yeah, that's right. Okay, so I did do that part. Okay, but so I am in tune with I am chug, but that's I think this part I didn't really get, and this comparison binary search. Huh, I was trying to find that binary search recurrence, but let's see. Let's actually read this first. For all I, and it's that if P works. And find T sub I using prefix sum, binary search. We use a form. Hmm. I might have to sleep on this one. Uh, yeah, overall I did okay, I think. Probably could have been faster, probably could have been worse. Okay, wait, there's another x is greater than equal to 0. If x is less than 0, k must be greater than n over 2. Or else it'd be, yeah, okay, obviously. Some easy formulas for k. I clearly did not do enough math for this one. This is way good explanation. Mad props to throw away at Coder. Because I think I was close in the ideas, but I didn't really do the actual math. Um, different sizes, sums of I. Huh. Well done, Foley. Wow. Why, why does this? Is this a contest code? Because why is there so much comments? Oh, it's practice. Okay. Still mad props. uh, yeah, okay. Cool. Well done. I was doing something similar, but not for the math. I missed some maths. I probably could have worked it out, but only in retrospect. Once you know the answer, you probably could always work it out. So who knows? But yeah, how do I see my standings? Like roughly, is there no rough standings? I don't even know how many points I got because it doesn't tell me. I don't know how these things work. That's almost like 120-ish. Could have sworn sometimes I see other people doing the virtual contest and it shows up. But yeah, well, okay. Anyway, either way, it was a good practice. Seems like I would have finished in the top 600 or so, give or take, including the unofficial people. Maybe I don't know if that's true, but give or take. No, okay, I was wrong on that one. But okay, cool. Since it's 4 a.m., I will see y'all tomorrow. Thanks for watching. Thanks for checking out. Let me know what you think about. Oh, I didn't change the screen so that it shows everything, but it's okay. Anyway, I will see y'all later. Bye bye.